In this report, we choose Rolls-Royce as our target firm and attempt to provide a strategy to help it develop core market competitiveness in the future and end the concern about mega chains. This presentation will be conducted in 4 sections. Firstly, we will use short pages to provide an overview of Rolls-Royce and introduce the mega chains being discussed in the report. Then we will analyze how Rolls-Royce responds to the mega chains in business planning and review the weak points in the context, followed by the possible reactions that Rolls-Royce could be considered to address the issues. Finally, in the strategy section, we provide critical recommendations for Rolls-Royce to implement the changes. So let's start with the brief introduction about Rolls-Royce. Rolls-Royce is a multinational which is based in the UK. It was founded in 1884 by Harry Royce with the business in engineering and motor cars. Then Rolls-Royce developed its defense business from the 2 world wars. Nowadays, Rolls-Royce relies on its advanced turbines to become a firm providing energy power solutions in the civil and defense domain. The civil aero engine business is sitting in the leading position of its revenue structure, followed by defense and power systems. MTU as Rolls-Royce subsidiary covered the business about various power systems, power generation, power supply for marine and railways. The revenue affected by the aero engine business reduction was due to the COVID-19, has a dramatic drop at 2020, with the future remains challenging. After learning about Rolls-Royce business, let's move the scope on the mega chains. In this report, we are going to focus on 4 identified mega chains and show significant impact on the future of power industry, climate change, sustainability, globalization, and technology. In brief, the growing concern on climate change issues has forced the firms to adopt sustainable strategy in business operation in the future. This might be challenging for the multinational running distributed network globalized. Decarbonization is becoming the new change in technology innovation, including the technical path through electrification, sustainable fuel, renewable energy, and nuclear. Digitalization is underlying roles towards the sustainable future that provides effective management support for the new power solutions, like the scope showing on the slides.
In the Analyze section, we combined with framework tools like business model canvas and market mix to analyze Rolls-Royce's strategy plan and behavior under 4 major industry trends: climate change, sustainability, globalization, and technology. Then reviews the shortcomings and possible improvement in 4 areas: research and development, supply chain, technology, and business model. Those figures are introduced the layout of Rolls-Royce's research and development in the whole life cycle and the global distribution of Rolls-Royce University Technology Center and the research centers. Rolls-Royce is very active in technology research and development to meet the challenge of climate change and cater to the zero carbon strategy. Rolls-Royce Global R&D Network now mainly focus on the research and breakthrough in decarbonization technologies. Rolls-Royce has established a unique global innovation network, including industry, academic, and research. According to the U.S. technology maturity level system, Rolls-Royce has formed 3 parts of different levels. Among them, level 1 to 3 is the basic research group to the University Technology Center around the world. And the university team organize a relevant technology research project. Other 2 parts, Advanced Manufacturing Research Center, focus on the commercialization of common technologies. Especially Level 6 technology is a key project for Rolls-Royce R&D funds, also known as system-ready technology, which has a certain degree of maturity, but is still far from commercialization, which is the core of the breakthrough. Moreover, the globalized R&D system poses a challenge to the interaction of different players. Rolls-Royce recognized the importance of a digital system for global R&D, and its R2 data lab is located in 5 countries and provides service and support for data interoperability at the R&D and production end. From the above, it can be seen that Rolls-Royce R&D system is actively utilizing the convenience of globalization and digitalization to improve its core technology research and development ability, and has given a lot of attention to the decarbonization technology in line with the trend development. However, in management, Rolls-Royce R&D system is a typical waterfall configuration. It spent 10 to 20 years due to the high difficulty of the decarbonization technology project and the complex technology network. Although the waterfall configuration is good for the schedule management of large projects, but in the future, the engineering technology will develop more quickly, and the market will change faster and faster. The disadvantage of inflexibility of the waterfall structure will be magnified. For managers, it is challenging. On the one hand, it is difficult to respond quickly to sudden changing during project implementation. On the other hand, projects need to reach the final stage before they can enter commercial practice, which will lessen the payback period, especially for Rolls-Royce, which has a high percentage of technology investment spending. A shorter payback cycle helps to circulate the capital flow. The A380 project is a typical case of market failure in the aviation industry. The development of the flagship model requires a 10 years project cycle. During those 10 years, the needs of the market have changed. Reduced passenger demands for hub-to-hub routes caused the A380 to be shut down just 16 years after delivery. For Rolls-Royce itself, its early composite blade technology failure led it adhered to the hollow titanium alloy blade technology route. Will did not reveal the changes at the material technology upgrade. But GE grabbed the potential of composite blend, which considered as one of the factors of GE won the contract of Boeing 777. Thus, it can be seen that Rolls-Royce needs to improve its flexibility and commercial application efficiency in their R&D structure to ensure it can lead a position in decarbonization technology. Rolls-Royce's globalization strategy is not only focused on technical cooperation, but is also reflected in its globalized supply chain system. Rolls-Royce has more than 18,000 active suppliers in more than 10 countries and regions. The main areas are Europe, which is close to home, and Asia and North America, where there are close business interaction. The globalized supply chain system enables Rolls-Royce to gain the cost and technology advantage brought by industry cluster. In order to effectively manage the supply chain system, Rolls-Royce applied digital management systems such as Airbar Info and global supplier portal to improve coordination efficiency. Despite the benefit of the global supply chain for Rolls-Royce, climate change and sustainability trends have brought the issue of supply chain decarbonization to the fore. Rolls-Royce has centered the strategy on the both net zero for its own production and operation activities and production emergency control, and the supply chain has become the second large source of carbon emergency for Rolls-Royce. There are objective factors in different of managing carbon emergency from the global supply chain. Local differences in emergency policies and industry foundation have led to uneven decarbonization of supplier in different regions. Also, Rolls-Royce is aware of issue of supply chain carbon emergency and has taken measures, including carbon emergency review during supplier selection and decarbonization of supply chain transportation. Carbon emergency from supplier production practice remain the core issue. The lack of supplier carbon regulation and discipline could lead to threats to supply chain stability in the near future due to structural carbon regulation or import or export carbon reviews. The most pressing issue now is to establish a continuous supply chain carbon monitoring and target management system to understand the supply chain carbon emergency and integrate supplier decarbonization into the integrated management structure.
As mentioned above, Rolls-Royce committing to making its products net zero range by 2015. Electrification and clean fuel replacement are two most critical technology plays in the area of clean fuel. One of the first to be consummated proven was biofuel due to the production, process and waste transportation factories. It was temporarily not available in large, secure, and low-cost supply to meet the high demand. In addition, biofuel combustion still carbon emissions and is not a completely zero-carbon solution. Hydrogen, considered to be the more promotion sustainable fuel, although it's still mainly produced by fossil gas at concentrated state. It can be produced with zero carbon when the electricity technology is mature. More importantly, the duration of hydrogen of ancient and totally zero carbon. Rolls-Royce should further consider the commercial promoting hydrogen solution. Hydrogen production from nuclear power plants is considered to be the most promising option at present. Suitable zero-carbon hydrogen production can be achieved by electrolysis of high-temperature water vapor generated from nuclear power plants. Although this option has the related cost advantage, it's still expensive. The soil oxide electrolysis technology for nuclear power plants is a new decreasing and variable market. It can achieve action and low-cost hydrogen supply. The nuclear power plant hydrogen generation solution also offering new opportunities for the future of Rolls-Royce. SMR. Although SMR had considered an operation cost advantage over conventional nuclear power plants, its cost performance is still low compared to other power solutions. While interest in nuclear power remains high in the developing countries, some developed countries have moved to reduce their reliance on nuclear power. Therefore, SMR projects need to offer more value to potential consumers in order to be convinced the hydrogen production fraction will allow nuclear power plants to their more economic benefits and achieve the zero carbon sales for the future power and transportation security. Thus, development of hydrogen production from nuclear power plants can bring more potential to Rolls-Royce business. A piece of electrification seems to be factor compared to the application of hydrogen. Electric hybrids are at the near-term achievable decarbonization options. Small aircraft are prepared for electrification. The importance for electrification is clear for Rolls-Royce decarbonization strategy. Rolls-Royce had not only developed the management system for distributed power to support different form of hybrid solution, but also collaborate with several companies and institutions to develop electrified power system for different use and sale for aircraft. With Rolls-Royce reach technical reserve in turbofan acknowledge the vital component, which is the key to hybrid power. This Rolls-Royce weekly, Rolls-Royce plan to invest $18 million in energy storage technology development in the next 10 years. Also, electrification can effectively reduce carbon emission and have relative motor application in the automotive. However, the carbon footprint for quality components themselves is an area that considerably tension. Lithium batteries, which mainstream for the advanced induced, have very significant carbon emission rate for their production emissions, especially for rail, metro application, and depolary material production. In addition to optimization production technology, quality resale is also an effective means to reduce carbon emissions. There are two options for quality reselling: raw material reselling and garden redirection. The raw material reselling process still leaves a carbon footprint. The decommission process that at least 80% remains sales can be used for other quantity need. Installation better reselling can reduce product costs and thus improve market competitiveness. Thus, in context for the process of rapid development of electrification, Rolls-Royce should focus on the development for low carbon reselling technology for batteries and insulation, adhering to further establish its business advantage under the stimulable strategy. In addition to the effectiveness on the technical stage, we also see the limitation of Rolls-Royce's exciting business model and its negative impact on supplicability. It's clear that currently all engine manufacturers still focus on the traditional production and sale model and earn their main revenue of the post-maintenance service. Airlines and aircraft operators are their core customers. However, the agency selling price of aircraft make the heavier degree of aviation industry significant. The health security Curatory makes a scored mark as little incentive to change to new energy, and the incremental mark is affected by epidemic. Application will remain various in the future. Overall, the have three complying with the impact of the deployment makes customer cautious in their decision to purchase a new product. On the one hand, market demand is not realistic, and on the other hand, the penetration for new knowledge in the evaluation scheme is low, and it takes a long time for products with carbon emission advantage to gradually replace the old ones. Therefore, trying to change the business model is one of ways to build future competitiveness. With development for modularity, its improvement for energy compatibility and provide the possibility for engine leases business. Under the engine leases model, customer no longer need process engines, so reduces ST investment. Incremental market demand will be opened. In addition, the leases model also completely changed the structure of inventory marketing. Airline and aircraft leases only need to pay a higher leasing and need price to immediately change to energy efficient engines, as long as their overall operation cost file. 4. Opening up the leasing model will enable Rolls-Royce to differentiate itself and rely on its user base to achieve barriers. It also fits with Rolls-Royce sustainability strategy to bring low-carbon products into commercial operation more quickly to improve the decarbonization facilities of aviation industry.
To deal with the shortage mentioned in the previous analysis, we provide the following strategy to help Rolls-Royce adopt the changes in the practice. Firstly, to improve the feasibility of technical innovation and shorten the investment cycle, Rolls-Royce could consider to introduce agile idea into R&D management as a supplementary strategy to traditional waterfall structure. Secondly, to help strengthen the market competitiveness of Rolls-Royce decarbonized products, more technical investment should be paid to the battery recycling and hydrogen product areas. Rolls-Royce should establish cooperation with leading firms on battery recycling to work on the net zero battery material recycling technology. Furthermore, Rolls-Royce could work with its IT partners to provide a more efficient battery stageable utilization management system to extend the life cycle of retired batteries. For example, retired batteries from plane could be used for storing renewable energy in microjet system. For the idea of hydrogen production in SMR, apart from the measured electrolysis solution, Rolls-Royce should work on the SOEC technology for the broader perspective on scale production of hydrogen in SMR. Actually, Doosan in Korea has already started a tap on similar roles. Thirdly, to strengthen the monitoring of supply chain carbon emission, Rolls-Royce should cooperate with world-leading test agencies and IT partners to create a digital carbon emission management network. For example, the SGS Group has already published its first distributed carbon emission system. More specifically, the establishment of digital carbon emission management network could introduce embedded blockchain technology to ensure the reliable and recoverable data transmission. The AI technology could adopt in the mass data analysis to help managers setting visionable goals to urge suppliers works on the decarbonization in their operation. Finally, to implementing the engine lease service, Rolls-Royce should pay efforts on the development of software and hardware. The major change of lease model comparing with the traditional sales after-sales service model is the further highlight of service quality. It requires a more effective response to the customer demands. In the software part, Rolls-Royce should work with IT partners to develop an integrated engine management system that allows Rolls-Royce to allocate engines combined with the customer operational chains to maximize engine utilization while maintaining service efficiency. The existing EHM service to single engines will be connected together for management. The software update will expect to apply more usage of AI and IoT technology to build effective capacity. While on the hardware part, Rolls-Royce should develop service centers that covers major airports worldwide and to provide engine replacement service for customers and handle the engine care task. This could be achieved by cooperating with local airport service teams and also the existing Rolls-Royce authorized partner.